Hi everyone. I'm super curious to know what Jetro did 20 years ago, and now I'm happy that I'm not the only one. Welcome to this talk where Jetro walks through the maybe making of Stair Dismount and the maybe ideas behind the concept. We'll see.
Okay, thank you very much. Okay, so hi. I'm a creator of a game called Porrasturvat, which is also known as Stair Dismount. And it is one of the first games with the ragdoll simulation for gameplay. And I created it about 20 years ago, and the project originally took just 2 weeks to make. And I didn't really have even earlier physics simulation creation experience, so it was very much of a learning project for me. And people apparently think that the concept is quite funny because the game won the first ever assembly game development competition 20 years ago, and yesterday it again won an All-Stars award. Thank you very much. So later the game also got some sequels and even became a commercial success, but now I will concentrate mostly on the early stuff, which was the game was just made for fun. So what will I tell you about today? Some words about what happened first, why did I start the project, and how did I get started. Mostly I will tell you details how the project went forward, also some differences, what was changed later in the sequels, like truck dismount, dismount levels, sauna dismount, and what happened after the initial release of the original game. So where did I get the idea from? There's a quite simple answer to that. One day I was coding something and then I went out to have a lunch and I tripped in the stairs and almost fell down. Luckily I got hold of a handrail. The game doesn't have one, but I tested having one, but I just left it out. But from that I got the idea, what if I make a game out of that, an actual simulation? And back then I had just gotten interested in physics simulation, and now I had a clear goal. You know, it's easier to learn something when you create something on the way, and that was very nice. So what I did first, I searched around the internet. Back then it was maybe even Alta Vista. Google wasn't a big thing back yet, and I found 2 enablers for this project. One was Open Dynamics Engine by Russell Smith, and the other one was an editor called Juice. So why did I went to look around for tools at the very early phase? So if you try to make some physics simulation from scratch using a plain engine and you handcraft stuff, you will find out easily that it's even a little bit complex physics setups. It's very cumbersome work to create those. The creation, testing, the iteration, and finding what works and what not. So here you see the Juice editor, which, by the way, even had the same engine, physics engine inside, ODE. So it's a simple editor for complex things, and it was very excellent finding for me, because now that I had a ready-made editor, it also meant that I had faster iteration time to create the ragdoll for the game. So here we can see that just in a matter of tens of seconds you can create simple simulation. And in this video we also see what you can find in the Juice examples folder, what kind of structure. So the editor allows you to make even very intricate simulations. And it will also expose you to the fact that it's quite hard to make something very stable and very working, so things easily break down. So let's walk you through how did the ragdoll got made. I'm sorry that I don't have videos of the very first test how to make a ragdoll. But anyway, when making the ragdoll, the first tries, they really didn't feel right when you try them in the editor. So my wife, Sarah, she suggested that I would find information about some real human bodies and try to match what I can find. So I found some medical data on the internet. And to be honest, it was very detailed, very complex data and kind of hard to apply directly because computers are slow and I needed to keep this ragdoll very simple so it would be real time. So most of the data was unusable. But despite all that, the research phase was very meaningful for the end result, even if the ragdoll looks very simple. So the Juice editor has this nice feature that we can see the ragdoll here, but you can pick and drag body parts. And this was my main testing feature to see how the ragdoll interacted and worked back then. It was very good stress testing for the ragdoll as well. And well, I have to say that I had some really nice laughs as well with the first ragdoll. So next year I made a sequel called Truck Dismount. In that game you can place the ragdoll inside a truck, and I added a sitting variant, but there's otherwise nothing special with this version. And even later I made a sequel called Dismount Levels. ODE engine had got some optimization up to that point, and it was possible to find a little bit ways to increase the complexity. And I tried to make the ragdoll more sophisticated, but I learned a lot back then, but in the end I actually made only one meaningful difference, which is the shoulder setup. The first version used a ball and socket, a spherical joint, and this Dismount Levels version, it uses a hinge joint. So that is still very unrealistic, but in the opposite direction. So a spherical ball and socket joint, it has too many degrees of freedom, but the hinge has too few. So this one is more like a stiff version of the ragdoll. Okay, so after getting the ragdoll ready, the next step was to create a Visual Studio project. I also have no builds or video of the very first steps, unfortunately. I have only a bunch of screenshots and personal notes from that time. But I did start to make saving binary builds just a little bit later in the project. So first thing was to create an XML loader for the Juice file format, and that even took something like 1 to 2 days using a library called XPath. And now it was time to start debugging. So at first I made some quite simple mistakes. The body parts I created there, they were too big and the physics just exploded, like you can see, everything just flies. And by the way, at this point it was maybe 5 days out of 2 weeks for the project. So the next day I got the scales and rotations fixed, and I started with loading and rotating each part to its place and setting up for the physics. And all this is very important step to get it just look right initially, even if you are not simulating it yet. And by the way, the simulation works so that you have 2 versions of each different part. The visual one, triangles, textures, colors, and a physical one, which is like here we can see sphere, box, capsule. And all of these have properties like center, rotation, size, for simulation mass, or material properties like bounciness and friction. And also when setting all this up, I had some issues in reverse engineering the Juice XML format. But luckily the email was already invented back then, and nicely Juice author Nate Waddaps, he answered email very quickly, and he even sent me a small code snippet to showing how to map the Euler angles correctly to quaternions. At this point I still hadn't yet set up the code for the joints at all, so when testing each piece just directly falls into the ground, and that's why you see a weird composition like this. But I kept adding features one by one, and at every step I test to see what happens. Here in this image we can see nice progress. Setting up some of the joints works now, and we can have at least flying limbs. So finally the ragdoll setup is ready, but the simulation looked like the ragdoll has an epileptic seizure, and it was pretty clear that something is really wrong with the simulation setup, and I still had a lot to improve. So I had to read more the ODE manual very carefully. Concepts like error reduction parameter, constraint force mixing, contact handling modes, and all what you can use to control and tweak the simulation parameters. So a day later, I had tweaked all the parameters enough so that simulation behaved mostly okay. But at this point, I was kind of blind all the different ways why something happens. So I hit a new issue that suddenly all the ragdoll pieces, they pop out from each other. And of course the reason is very simple, because the parts are colliding with each other and they pop out, and the joint handling is not too strong anymore, so they can't pull them back. So the epileptic feature was gone, but now it was so dislocated everything. But I was initially a bit blind to that, but of course the solution is to filter out the collisions between those overlapping connections. So now it is soon time to show you an actual build of an early test. And this is, by the way, just a simple ODE simulation environment from the example code. Rendering is a library called drawstuff, which is even used in the final game. And in this video, notice that you see the ragdoll has textures, and because the shoulder uses the ball and socket spherical joint, arms are rotating very weirdly around the long axis because of this joint setup. So you can maybe see it in the textures in this video. And also back then my main feature for testing in-game was to press spacebar so I can just lift up the ragdoll a little bit and see what happens that way. So let's compare that to running without textures. And this partially hides the problem. I didn't really want to spend more time on the ragdoll or try to find any fancy solutions at this point, so I just made a decision that the game won't use textures. The simple visuals will be enough, and the movement is what this game is all going to be about. So at this point, the core of the simulation was now ready, so it's time to create the stairs. And here we have the very first version of the stairs. Those are hard-coded in the game and not made in the juice editor. And now you have the chance to see very first dismounting in stairs, which has been never shown before. Let's see what happens. There it goes. So right after this, I then tweaked the stair setup to what you can see in the final game, and also implement all the red flashes for the ragdoll pieces and so on. So a bit more than a week had been used at this point, and I was ready to start doing small bits of polishing work for the project. And I made the very first standalone build. So here you can see the directory listing of Porrasturvat 0.1 build, and let's see what it looks like in action. Before that, at this point, I want to say that I was now finished tweaking the simulation parameters, like settings for the ragdoll and the material. And I ended up choosing ODE contact bounce collision mode with small amount of bounciness, but even more importantly, I selected that there's an infinite friction mode so that it really never slips. And that's much more dramatic in the game, because normally you would quite often end up sliding down stairs in a way, and that's kind of half prevented in the game. So let's see what the 0-point version looks like in motion. And actually, this is almost identical what is the 1.0. And at this point, I still had this spacebar to lift the ragdoll feature that I was using for testing. Okay, so let's switch gears a little bit. So I tell you a little bit about the application structure and basically lack of UI. The ODE draw stuff library, it really runs the show in the game, but I made a SDL port out of that, and that makes the game like event-driven in a simple way, and the game is also just a very simple state machine. Some of the important stuff happens in the state transition phase when you go, for example, from hit setup to dismounting or back. Then it resets the physics engine, recreates all the body parts inside the physics so that it is reproducible or deterministic. So the game has one main update function that does a simulation step if it is time to do one, or if the game is not paused. And then it just renders whatever belongs to the current state. And there's one command function which handles all the keyboard mouse events based on the state, also things like Alt-Enter for full screen, pause game, reload graphics, and so on. And since I had a tight deadline, lots of the code is really simple, quick and dirty, copy-paste. It's kind of awful to maintain, but easy to write and forget. And even there's no UI system, I just draw a static image on the screen, and then hard-coded check for the event coordinates against the rectangle if I'm clicking inside the rectangle. All these kind of hacks. A few words about the audio. Like everything, also audio was put together in a mad rush. I used a library called Fmod for the technical side. The code is really simple, but it has few ideas to make this semi-interesting audio. So the sound effect has categories for head, body, limb, and some code which prevents playing the same type too soon, but you can have different types simultaneously. And also I did some small experiments of feeding the physics hit parameters, what happens when a hit comes to the audio, but that didn't really work. I used that for the red flashes, like velocity and so on, but not for sound. And for the sound effects, I gathered samples from many sources. One sample is just a bass drum, but the result was first a little bit dull, so I asked help from friends. So my friend Ville, he made some vocal samples and also the signature scream you can hear in the game. My friend Simo, he had some ready-made songs, and one of relaxed tune really stood out, and it provided a nice, absurd contrast for the game. So I was quite happy with the result, even that it was very quickly done, the audio side. So about finishing the game and version control, you can see that it's just a pile of zip archives, but it was very nice 20 years later because it was plain data, binary builds. It was very excellent for trip down the memory lane. And in the first zip file, at that point I had only the XML loader, and the last zip file is the fully finished game except for the score system. So it was a bit less than 2 weeks at this point, and 1 or days more to add the scores and the online submission system. So 1.0 was ready. And for the competition submission, the server-side score system only had a spec, no implementation at that point, so the client submission was totally untested, but it still worked out when I made the server-side implementation. For the sequels, I later used the version control system, CVS from the 90s. I'm not an early mover with version control storage systems. Nowadays I use Subversion or Git, but I'm still making these zip files. So let's switch gears a little bit again. Let's talk about what happened afterwards, about the reception. And by the way, when you have online scores, it means that it's a kind of open invitation to cheat or hack the game, and it's an interesting challenge. And by the way, I just recently enabled again the online score, so go download the old build and make an assembly score record. I have a few words about the Linux and Mac ports and about the sequels. So about the reception, well, like I said, the game won the gamedev competition. A bit later there was posting on the Slashdot front page. Back then it was kind of a big deal. It meant like there was very quickly 200,000 downloads. With Truck Dismount about a year later, together it was very quickly like 1 million downloads. Later with commercial release, it's tens of millions of downloads. But from the Slashdot post, a very interesting replies I got. For example, someone called John Nagel from Animats, he said that he had a patent for a guy falling down the stairs from 1997. Well, he had a different algorithms and everything, but it was very funny to hear that someone had patented the idea or technical implementation. And lately I have been making some networking code and hit again this Nagel guy, because any networking coder knows that the TCP IP has this algorithm called Nagel's algorithm, and the same guy is famous for that. Also, I got some very nice feedback emails, quite a lot of those. Some of them were very strange, like just changed my life. Also recognizing these random situations. Back then I was driving an 80s Ford Escort, and then when I sold the car, the office clerk who I sold the car to, he just randomly asked, "Did you make Porrasturvat?" How did you know about that? And also I learned back then that the bugs or glitches in a game like this, it's actually very okay to have some. People really like that stuff because it made the game more fun. Some people even lacked proper OpenGL drivers and the game run like molasses, but even that seemed to be okay for quite many people. So a few words about the online scores, cheaters, hackers. I have to say that if you find a glitch in a game just by playing, mostly that is okay way to get the high score. I only did a few very small fixes afterwards to prevent the most obvious ones. But when you have this online score system, it's of course it's a competition, but for some it's how can I hack the system? And for me it's a challenge how to prevent it. Well, I had a tight deadline, so I just decided, okay, I want it so that it's not going to be easy, but I can't really prevent it. So what I did was to obfuscate things a lot. I used a CFL pack file system from friend Jari. I wrote a custom encryption plugin to hide the ragdoll data. I used the executable file checksum to validate the executable, but if the validation fails, it doesn't prevent you from playing the game. It's only submitted to the server score validation system. And also the submission data is obfuscated, and there's the same data submitted two ways. And one is a composite data and one is just different pieces, and all this is compared together in the server side. So there's a few different ways to validate the score. Of course, someone still hacked the system and submitted a high score at some point, but there was only a few of those. Back then I published a congratulations in the score system, and I was asking, like, tell me how did you do this? Please send me email. And it worked. Someone emailed me. It turned out I didn't have efficient protection, enough efficient protection against memory editors. And all this feedback, it led to small fixes for both Stair Dismount and Truck Dismount. But all this cheat prevention meant that there was no really any kind of support for modding the game. So Also a few more words about the Linux and Mac ports. Martin Sturge volunteered to make the ports, so it was not really my work to do that, but we ended up doing together some cross-platform determinism research, and it was very interesting. The game already had a replay mechanism, so it is deterministic in a one single play session. But when you try to run different platform, and then you can notice that there's so many different tiny mistakes you can make in the code to make it non-deterministic. Any source of randomness, timing issues, compiler, GCC or Visual C back then, optimization flags, compiler version, C library version, CPU type. It was back then Intel or PowerPC, FPU type, FPU mode. And the determinism breaks when you change one of those. So floating point math, it doesn't have a very good generic solution for determinism. But after careful testing and carefully selecting where we have the fixed variables selection of the tools, we got really good results. Like we can't claim 100% between all the different tries, but it was a nice learning project. All of that stuff didn't end up in a released version, but it was very nice to find something like this and research it. And this is one of the reasons why I'm still very interested in the fixed point math. Even today I have a private version of a Unity mathematics package and a burst compiler running with fixed point math. And maybe a few words about the making ports just for the sake of supporting different platforms. Now later I kind of question if there's value in that, because for the simple reason that if you have an Apple platform or Linux, basically a binary build will last you only a few years, and then it's going to be broken and nobody can run it. And for some reason Microsoft values the backwards compatibility much higher, so this 20-year-old build executable of the game, it still runs perfect in the modern Windows as well. It's interesting. So a few words about the sequels and more. I made next year a game called Rekkaturvat, Truck Dismount. It has different gameplay, less timing, more planning. The truck is very simplified hack, not an actual vehicle simulation, just arbitrary force pushes it. I had a private tool to download the best online score and validate locally, but I didn't want to make an actual server-side build because it's so CPU intensive. And actually for this game I made UI system which was used in many of the later sequels. Next year I made a Dismount levels preview. It was kind of technology test. No real gameplay, it's just a simple example level, because it was finally a platform for modding or actually creating new Dismount games. And there was a small community for it. The result was 10 to 20 wildly varying Dismount games, and it was technically a big leap forward. It has a built-in level editor, really easy to use, and there was a scripting language with a simple API. I updated the project for a while, but it still died before really taking off. Also, my beta testing friends got some inspiration to make parody of the game. They made a live act video, which I was a little bit worried about because, you know, it's dangerous. This was in the Assembly 2005 short film compo. And after a few years of pausing, Dismount is back with Sauna Dismount, Porrasturvat. I originally planned to make just a sauna game, but somehow I ended up making a sequel. Technically, this was again a big step, this time mostly with the rendering. I wrote my own light baking tool. I switched a different engine, open source Erlicht engine, and this was in Assembly 2008. And I'm not going too much into the commercial history of Dismount games, but just a few words about the first one. We made a mobile Stair Dismount Touch, later just Stair Dismount on the mobile platforms. Technically it's mostly same than the Sauna Dismount, OpenGL ES port of the engine. It had some extra optimization effort to squeeze out what you can from the early smartphones, and it won the Independent Games Festival Award, Technical Achievement Award. And the Sega still continues. So here's a big slide with thanks to ones who helped with the original game. There's quite many of you. Thank you very much. So finally, thank you for listening. It's maybe now time for questions and answers. Please note that I'm not part of the recent development of with Dismount games. If you want to know about the latest and the future, go to the next session. You will learn more about the recent development with the same ideas stuck in the same stuff. So, time for questions, and thank you very much.
Thank you, Jetro. Maybe applause first, and then if you want to ask questions, raise your hand and I will bring the mic. Yes.
There's one question.
Yes, hello. What is your reason for still using SVN and also Git? But like, what is your reason for still using SVN instead of Git in particular instances?
I think it's a good question. I think Subversion is much better for a project like Unity when you have a lot of binaries, assets, as well as source code. If you use Git just for source code, it's like really good, and all the GitHub stuff, especially for the tracking and issue tracking, all that, I love it. But for like, if I have a Unity project, I prefer to put it all in a Subversion, and the Git history system is not very well suited for that, and the binary support.
Can you clarify on the cross-platform determinism? Did it mean that if you ran the same replay file that you made in Windows on Mac OS, it would give you different results?
Yeah, that was the problem, that if you, for example, I made a Visual C build for Windows, and then later we used the GCC in Mac, and even on a Power PC, so everything was different. But we found that if you select the compiler, like use the same compiler on each platform, you control some FPU parameters so that they are very close to each other, select carefully the optimization flags and all this, it is possible to actually replicate the simulation quite nicely. Maybe not 100% of the time, but we were surprised how far you can go, even that you would think that it's almost impossible. But for some CPU architecture differences and compilers nowadays, it depends on the optimization. If you only prevent certain FPU instructions, then it's possible to get determinism, but because there's a great difference in the CPU architectures. But it's an interesting area of research. I hope this answered the question.
Other questions? I guess not. So congrats again for being the all-star game dev combo winner. Of course, you and your team.
Yeah,
and thanks for the presentation.
Thank you very much.